In this video, you will learn how architects use encapsulation. Also, is this related to security? You are watching Code Like an Architect series with Adil Ata on ArchiWisdom. Suppose you are making an application for a bank account. You have a bank account class with an attribute balance. If you think about the nature of this balance attribute, you will realize that it's central to your domain. Balance is something that gets updated with almost every operation that you do. When you withdraw an amount, it is deducted from the balance. When you deposit an amount, it is added to the balance. Similarly, when you pay a bill online or make a purchase using a card, when you transfer money, when you receive your salary, when the bank charges a monthly recurring fee for its services, in all those scenarios, the balance attribute is updated. If you jump straight into the development without realizing this very nature of the balance field, you will end up with different pieces of code throughout your application that manipulates the balance attribute. And this type of coding will cause several problems down the way. Since the balance field is being modified all over your code base, what happens if you need to make a change? What if the bank decides to charge an additional fee on every withdrawal? There are so many forms of withdrawal scattered all over the code. What if the government introduces a new tax every time you receive an amount? What if there are some customer complaints suggesting a bug in balance calculation, incorrectly deducting extra amounts? Since this is a production issue in a financial domain causing monetary loss, it might become a highest priority blocker. But what will you do as a developer? Troubleshoot the entire application? Would you like to add some logging? That's a good idea. But again, you would have to do this across the entire application. What if there are some concurrency issues, meaning two pieces of code running simultaneously with one overwriting the impact of the other? There are many different ways to solve this. You can use a pessimistic lock or an optimistic lock, or you can change the algorithm of calculating balance to a more concurrency-friendly algorithm. The problem is that any code level solution that you come up with must be applied everywhere the balance attribute is modified. It's not easy to find all those places. It's a lot of work and you might miss some places. I hope as developers we all can feel the pain of being in these situations. Question: what do you think we could have done differently to avoid running into this situation? Do you know the answer? Think about it. It's just a single word change. If you know the answer, stop the video, leave a comment, and then verify your answer in 5 seconds. To prevent this situation and improve overall code maintainability, all you needed to do was this. The moment you realized the nature of the balance field, you should have made this attribute private. By making the balance field private, we ensure that any code manipulating the balance field is contained within this class. This means that any code throughout the application that needs to manipulate the balance field will be forced to go through this class. No matter how complex the manipulation logic is, we know whatever it is contained and enclosed within this class. Now, if there's a change, I only need to understand what's written only in this class, not the entire application. If the bank wants to charge an additional fee on every withdrawal, I will change only this class. If the government introduces a new tax on every deposit, again, I will change only this class. If there is a production bug related to balance calculation that I need to troubleshoot, or if I need to add some logging, I will come to this class. If there is a concurrency issue and I need to make some adjustments, it will be a single file change, not an application-wide change. That's how you can use encapsulation to take your programming to another level. And that's how architects use this. Think about it. As a developer, you are more concerned with the implementation details. But as an architect, you are focused on the quality of that implementation. In this particular scenario, your primary concern is maintainability. You are not interested in the exact functional requirements and the implementation details. Instead, you want to ensure maintainability. You want to make sure that whatever code is written should be maintainable. And that's how you have used encapsulation to set up things in a way that ensures and enforces maintainability. That's how architects use encapsulation. That's how architects use object-oriented programming. And that's how you can use it too, to code like an architect. Also note that all of this is the impact of doing just one right thing in the right place. It's not even a one line change, it's a one word change. Referring back to the mindset video in the same series, what we did here is simply a little analysis, followed by thoughtfully applying the right feature in the right place. That's it. All of this is the impact of using just one access modifier. Finally, is encapsulation related to security? The answer is no. Encapsulation and data hiding has nothing to do with the security. Yes, we just saw a banking example in which a class is trying to hide its balance field. And we all know that there are some special security concerns associated with banking and financial applications. But please make sure that this banking example doesn't confuse you. Please make sure that you don't confuse encapsulation and data hiding with security. People often do that. Maybe because of the word data hiding, or maybe because a class actually hides its data from other classes by making it private. But you need to understand that making something private doesn't make it more secure in any way. It doesn't protect against hackers or any other malicious users. It only hides it from other classes. Why? As we saw in this and in previous videos, for maintainability, not for security.